Can you see my screen?
Yes.
Yes. So this is your fifth practical, measurement of infiltration. So last week in our lectures we will discuss on this infiltration. So what is infiltration?
It's the vertical movement of precipitated water into the soil profile.
Yes, good. So if the soil is saturated, what will happen for the precipitated water?
Runoff.
Yes, runoff. Then what are the factors affecting infiltration rate?
Soil type.
Soil type. Soil characteristic. Yes, precipitation.
Moisture content.
Moisture content. Then
organic materials in soils.
yes, organic materials in soils and land cover. And we discussed on how these factors affecting the infiltration rate. So in today's practical session, we will discuss how to measure the infiltration. Soil properties relevant for water movement are very important in evaluation of land for agricultural potential. The most significant parameter is determining the entry of water and its movement and its retention in the soil. Think if a land has low infiltration capacity, then what will happen if you plant on that particular land? That land is very low infiltration capacity. So at that time, you need to irrigate for your plants. So what will happen if low infiltration capacity? So most of the irrigated water is lost from runoff and evaporation. So plant can't utilize the irrigation water. So is that good for the plants? No, right? Plants need more water for their growth and other activities. So if a soil has low infiltration capacity, we need to irrigate frequently. Why? That soil can't hold that water. So frequently we need to irrigate. And if a land is compacted, what will happen if the land is compacted? So there is no space in between these soil particles. So infiltration is very less. So how this land will compact? If you take an agricultural land, so previous harvest, that residues are remaining. Sometimes for the harvesting purposes, you use some vehicles like tractors or something. So if these vehicles go on that agricultural land, with the weight of that vehicle, this soil gets compacted. So before planting, what is the first thing you are going to do in your land? First thing is land preparation. What is land preparation? You have to prepare your land for planting purposes. So first, you have to do the plowing. So mainly, there is two major things, primary tillage and secondary tillage. Have you heard about this primary tillage? Why this primary tillage is important? So normally in the primary tillage, you have to dig your land for a particular depth. So why it's important? Sometimes your weeds and previous harvest, these residues are inside the soil. So once you have to plow the land, it will come outside and you can remove easily. So in the primary tillage, you can use some small board plow or disc plow like things. You can plow your land. So at that time, this compacted soil is cut down into big particles. After that, secondary tillage, you are going to do the secondary tillage. That time, it will make it as more small size clods. So the fine soil particles are coming out, and you need to level your surface is important. So these are the major things you are going to do by plowing. So what will happen after the plowing? These soils are making into small clouds. Then there is a space.
Recording in progress.
A space is creating in between the soil particles. So at that time, it will facilitate the moving of water. So if you plow and do these primary and secondary tillage, your land becomes more infiltration capacity. The infiltration capacity will increase. So once you irrigate that land, the water will move easily into the land and plant can easily utilize that water. So this is the important thing in plowing. The infiltration is the vertical entry of water into the soil at the surface and its subsequent movement downward in the soil. The infiltration capacity of the soil is very important in the agricultural purposes. Infiltration rate is the rate at which infiltration takes place. It's expressed in depth of water per unit of time, usually in millimeter per hour. Rate is at a particular time, what is the depth of water will infiltrate. So the unit of the infiltration rate is millimeter per hour. There are three methods used to measure the infiltration rate of the soil. The first method is natural rainfall method. Second one, inflow-outflow method. And the third one is Infiltrometer method. So in today's practical, we will discuss about this Infiltrometer method. In the Infiltrometer method, we can use double ring infiltrometer or single ring infiltrometer. So mainly we will discuss this double ring infiltrometer. In this picture, you can clearly see there is two rings. So that's why it's called as double ring infiltrometer. No need to draw this picture now. I'll show the detailed picture, then at that time you can draw it. The double ring infiltrometer is often used for measuring infiltration rates. There are two operational techniques used with the double ring infiltrometer for directly measuring soil infiltration rate. So there are three methods used to measure the infiltration rate. So in that, double ring infiltrometer is one method. So in the double ring infiltrometer, we can use two methods to measure the infiltration rate. First one is constant head method. The second one is falling head method. So any of these methods we can use to measure the infiltration rate by using double ring infiltrometer. The principle of the method is to observe the fall of water level in the inner of two cylinders driven concentrically into the soil surface. So in the double ring infiltrometer, there are two rings. This is outer cylinder or outer ring, and this one is inner cylinder. The principle of this method is to observe the fall of water level in the inner of two cylinders. So we need to fill water in these two cylinders, but we need to measure the fall of water only in the inner cylinder. So the inner cylinder is used to measure the drop of water level. Rings with measurements confined to the inner ring. The outer ring minimizes the error due to flow divergence other than vertical. So this is your land surface. Once this precipitation or other forms of water reaches the soil surface, then it will move downward. So this is called infiltration. So once the water move inside the soil, then it can move further vertically or it can move horizontally or laterally as well. So in the double ring infiltrometer, there are two rings. So once you pour water in the inner ring, the water will move vertically down and also it can move laterally. So what is the purpose of doing this experiment? We need to measure the infiltration. So if the water will remove as seepage, it's an error in your reading. So we need to avoid these types of movement other than vertical. So that's why we are using this outer cylinder. So once you fill the water in the outer cylinder, so the portion surround this inner ring, it's already filled with water. So once you pour the inner ring, the water will automatically moving as vertically. Why? The lateral portions are already filled with water. So it's moving only the vertical. So that's why we use this double ring. If we use only the single ring infiltrometer, the error is something higher than this double ring infiltrometer. So the outer ring minimizes the error due to the flow divergence, that is the lateral movement, other than vertical. The measurements can be carried out on the topsoil as well as on each of the subsoil horizon and substratum. In this case, the soil above the horizon is removed. The outer cylinder is replaced by the pit wall. So this is your soil layer. We can divide the soil layer into many portions. This is called horizon. So there are many horizons in the soil layer. So in the infiltrometer method, we use this topsoil portions. This top horizon we will use. So we need to dig a hole and insert your infiltrometer in the topsoil portion. The soil above the horizon is removed. The outer cylinder is replaced by the pit wall. So once you dig a hole, this is that soil pit. This is your boundary of that hole. But you need to insert your cylinder here. So your cylinder wall replaces this soil pit wall. Shall we move to the next slide?
Okay, ma'am.
Okay. So now we will discuss what is the principle behind this. The rate of infiltration is determined by the amount of water that infiltrates into the soil per surface area per unit of time. At a unit of time to the particular area, what is the amount of water infiltrates? This is mentioned as infiltration rate. The infiltration can be measured by either a single or double ring infiltrometer, with preference usually lying with the double ring because the outer ring helps in reducing the error that may result from lateral flow in the soil. So we already discussed this part. If it's only a single ring, the water can move vertically as well as laterally as well. So the error in your reading by this lateral movements. To avoid that, you can use double ring infiltrometer. Sketch of cylinder infiltrometer. You need to draw this sketch. This is the inner cylinder and this one is the outer cylinder. And you need to dig a hole and insert the infiltrometer the depth of 10 centimeter. The height above the soil surface is 15 centimeter. Then you need to fix a point gauge. It helps to mark the water level. So at which level you need to pour water inside these two cylinders. So that's why this point gauge is fixed. So these are the main parts. Inner cylinder, outer cylinder, and the point gauge. And you have to consider this height as well. 15 centimeter above the soil level and 10 centimeter below the soil level. An infiltrometer consists of two concentric cylinders of 25 centimeter height and made up of 2 millimeter thick rolled steel. The inner cylinder is 30 centimeter in diameter and the outer cylinder is about 60 centimeter in diameter. The inside cylinder is used to measure the infiltration rate, while the outer one is a guard cylinder for ponding water in the buffer area around the inner cylinder. So the diameter of the inner cylinder is 30 centimeter and the outer cylinder is 60 centimeter diameter. The total height of these two cylinders is 25 centimeter. In that 10 centimeter you have to insert into the soil surface and 15 centimeter above the ground level. And the thickness is 2 millimeter. So you have to take the reading in inner cylinder. In this graph, you can see the time in minutes and the accumulated infiltration. So this is the accumulated infiltration curve. So at the initial time, the infiltration starts. What is infiltration rate? Rate is infiltration over time. So, okay, this is your time and this is your infiltration and here this is your infiltration rate. So, at 2 seconds, your infiltration is 5 millimeter. So, what is the rate of infiltration? Infiltration over time. So, 5 over 2. So, the infiltration rate is 2.5 millimeter per second. So, at the end of, again, 2 seconds later, the infiltration is 9. Sorry, not 9, it's 4.5. So what is the rate? 4.5 divided by 2. Again 2 seconds later, the infiltration is 4 millimeter. So the infiltration rate is 4 by 2. Here the time, here we will mention the time interval. We start at 0. Then after 2 seconds, the infiltration is 5. After 2 seconds. Then the gap in between these two is again 2 seconds later. So what is the total time? 2 plus 2, it's 4. Again 2 seconds later. So 4 plus 2 is 6. So this is the accumulated time. We start from 0. First reading we will take on 2 seconds. Then we will take 4 seconds, 6 seconds. So the gap in between these two, this is 2 seconds. Here the interval is 2 seconds. So each 2 second time interval we will take the infiltration. So first, for the first 2 seconds, the 5 millimeter water, this is your total soil depth. So 5 millimeter water first move and collect here. Then again after 2 seconds, again this 4.5 millimeter water is coming down. This is 5 millimeter. After 2 seconds, again 4.5 millimeter water is coming. So altogether, what is the total infiltration inside the soil? Is 5 plus 4.5. Totally 9.5 millimeter water is infiltrated. Then after 2 seconds, again 4 millimeter water. Again 4 millimeter. So at that time, what is the total infiltration? 5 plus 4.5 plus 4. You have to add all these things. So that is called as accumulated infiltration. So first reading you can directly put 5 millimeter. Then the second reading 5 plus 4.5. It's 9.5 millimeter. Likewise, you have to add and write the values. That is called accumulated infiltration. That accumulated time also we can do like that. So that is accumulated infiltration. So that's why this accumulated infiltration value is going upward. This graph is moving like this. Why? So time to time, this infiltration is happening. We need to add each value and get the accumulated infiltration. So what will happen for this infiltration rate? Initially, there is more space in the soil. So water can easily move inside. So after some time, most of these pores are filled. So the movement of water is becoming less. Why? These pores are almost finished. So the infiltration will happen, but the rate, the amount at a particular time will increase. So at the initial time, the infiltration rate is very high. So with the time, rate is reducing. But the accumulated infiltration amount is increasing. Amount is increasing, but the increment rate is becoming less. So you should be very careful. This shape curve is for accumulated infiltration regarding time, and this one infiltration rate. Next, we will discuss what are the apparatus we are going to use for this practical. First one, the double ring infiltrometer. Then measuring cylinder, stopwatch, measuring tape, wooden plank, hammer, and plastic sheet. Why we are going to use this stopwatch? We need to mark the drop of water with the time interval. So we need to mark the time. That's why stopwatch. This measuring tape, these things, we need to measure the drop of water. That's why measuring tape is important. This measuring cylinder, we need to fill the cylinders. So that's why measuring cylinder is important. The purpose of this wooden plank, hammer and plastic sheet, we will discuss detail in the procedure part. In the methodology, first we need to select a suitable place for the experiment. So the site near or on footpaths, close to base of trees, near or an old termite mounds or visible cracks or insect holes should be avoided. So we need to select a suitable place and avoid these kind of sites. Why we need to avoid these sites near or on footpath? If we select a place while we are normally using for walking purposes, that soil is become compact. So the infiltration, normal infiltration is different from these types of footpaths. Then close to base of trees. So near the trees, their root systems are coming. So it's act as a barrier to the normal infiltration. So we need to avoid those places. And near an old termite mounds. So what is this termite mounds? Normally these termites dig small holes and remove the soil in that place. So at that time, we need to pour water inside our cylinders. That water is automatically go and fill the gaps which the termites used for their living. So it's affect our reading. And the visible cracks and insect holes. It's also like the termite mounds. This water is moving and fill that holes. So we need to avoid those things and select a suitable site. That is the first step. The next step is clip the vegetation and remove loose material which would float. So once your place is covered with grasses or bushes, first you need to remove the vegetation and clean the place. Sometimes these papers and something is inside the soil. So once you dig a hole, you need to remove those things. Why? It will act as a barrier to moving of water and it will automatically float once you pour the water. So you need to remove the material which would float. Then insert the cylinder 10 centimeter depth into the soil. The penetration of the cylinder into the soil must be uniform and vertical. So you need to clean the place and dig a hole nearly 10 centimeter depth. After that, you need to insert these two cylinders inside. The important thing is you need to insert those cylinders with uniform and vertical. That uniform depth and you should insert it vertically. The next step is install by driving them into the soil with home gate type hammer. Rotate the direction of the hammer blows and observe the distance between the soil surface and circular line around the cylinder to ensure uniform penetration. So your cylinders are like this. So you need to insert these two cylinders inside the soil. So that's why you need to blow your hammer around these edges. You need to give force to insert this cylinder into the soil. So at that time you need to consider you have to insert it uniformly and vertically. So you need to give equal force around this cylinder. The area enclosed around the cylinder has chance to get cracked while inserting the cylinder into the soil, which influence the infiltration. If the distance between soil and cylinder is more than 2 mm, the reinstallation should be done. So once you have to dig a hole in the surface, soil horizon, and you have to insert. So once you dig a hole more than 10 centimeter, think it's 15 centimeter, near to 15 centimeter depth you dig. But the height you need to insert is 10 centimeters. So there is a gap formed nearly 5 centimeter. But the minimum gap you have to maintain is 2 millimeter. So what you're going to do is you need to reinstall. So you have to fill it again and again dig a hole. So the maximum depth of this hole is 10 centimeter and 2 millimeter depth. So once you are using these hammers to installation purpose, you have to blow the cylinder. So at that time, the edges may crack. So you need to consider these things. You have to avoid those type of cracks. Why? If it's cracked, what will happen? Once you fill with water, the water will leak through those cracks. So it will affect your reading. So you have to consider these things. Next, place a wooden plank on the cylinders while hammering so that the hammer does not damage the brim of the cylinder. So earlier we talked that once we are directly use these hammers, it will sometimes it may crack the edges. So to avoid that, we'll use this wooden plank. So place this wooden plank on the cylinder while hammering so that the hammer does not damage the brim of these cylinders. After that, you need to set a point gauge or hook gauge in the inner cylinder to the desired level to which the cylinder is to be filled with water. So first we have to select a suitable place and remove the vegetation. After that you need to dig a hole. Then you have to fix your cylinders. At that time you should be very careful. You have to install the cylinders with uniformly and vertically. So for that purpose, we will use this wooden plank and hammer. After that, you have to fix this point gauge. It helps to maintain the desired level of water. Of the inner cylinder. Here you can see this is the plastic sheet. So you have to place this plastic sheet in the bottom of the inner cylinder to dissipate the force of water and reduce dispersion of soil while filling the cylinders with water. So what will happen once you're not going to use this type of plastic sheets? So you can directly pour your water inside the cylinder. At that time, with the force of water, the soil inside this inner cylinder, the soil portion, it moves here and there. So that dispersion of the soil will happen. To reduce that dispersion, we are going to use this type of plastic sheet. So first we have to place that plastic sheet in this inner cylinder, then pour the water. So first fill the outer cylinder to the depth of 8 to 12 centimeter. Then carefully but quickly fill the inner cylinder. So once you place the plastic sheet in the inner cylinder, after that you have to fill the outer cylinder first. Why? Once you fill the inner cylinder, the water is suddenly moving laterally. To avoid that, first we have to fill this outer cylinder and quickly fill the inner cylinder. Once you fill the inner cylinder, then quickly remove the plastic sheet, taking care not to disperse the soil in the process. So once you remove the plastic sheet, you have to remove it very quickly and avoid the dispersion of the soil. By using stopwatch, note the time for the movement of water and measure the drop in water height, giving an infiltration of water over time. So once you fix everything, then pour the water. Then immediately you have to on your stopwatch, and with the time you have to write down the drop of water level. So the drop of water height is equal to the infiltration of water. If the water level becomes too low, refill the inner cylinder. Use the hand or float or small plastic sheet to break the force of water. So earlier we used the plastic sheet because the first time we'll pour the water. But now already water is there, but the level is becoming low. So that time we need to refill the inner cylinder. And again, we can't place the plastic sheet on the bottom. So this time we need to use our hands or something like float or plastic sheets to break the force of water. So once we are pouring the water, to reduce the force, we will use our hands or float.
Excuse me, ma'am. Can you explain again?
So from which point you can't understand?
From this slide.
Okay. So now, so this is your inner cylinder. This is your outer cylinder. This is the soil surface. So now you fill the outer cylinder, then fill the inner cylinder. So now you can start the stopwatch. So it starts from 0 second, and you can remove the plastic sheet you placed here. So once you remove the plastic sheet, the water inside the inner cylinder will start to move inside the soil. So that movement is infiltration. We need to measure the infiltration. That's why we are using this double ring infiltrometer. So how can we measure this infiltration? The unit of infiltration is millimeter per hour. So by using the stopwatch, we can measure the time. Here, the measurements are here. So first, by using this pointing gauge, that point, you know the measurement. So think this is the 12 centimeter point. So initially the water height is 12 centimeter. After 5 seconds, the water level is going down. Why it will go down? Because water is moving inside the soil. So that's why the height of this water is coming down. So at that time, this height may be 12.9 centimeter or something. So in between these 5 seconds, what is the infiltration? What is the height of the infiltration? That is 0.9. Why? The difference between these two readings directly give the infiltration. So first it's in 12 centimeter. Now it's in 12.9 centimeter. The difference 0.9 centimeter is the infiltration during this 5 seconds. After that, another 5 seconds later, so totally 10 seconds later, your water height nearly 13.5 millimeter. So during this 5 second interval, what is the infiltration? The difference between 13.5 minus 12.9. So the difference is 0.6 centimeter. So the first 5 seconds, it's 0.9 centimeter. Next second, it's 0.6 centimeter. So at the end of 10 seconds, what is the total infiltration? 0.9 centimeter plus 0.6. So that is altogether 1.5 centimeter infiltration. So once this water level is coming near to the ground level, after that you can't measure the height. So that's why once it reaches the bottom level, you need to refill the water and again take the reading into this 12 centimeter. So you can continue your time, but the difference of height, it again come to the 12 centimeter. With the time, it will going down. So continuously, you can take your readings. Right? Again, it will reach the bottom level. Again, you need to refill. So likewise, you can take the reading. Clear?
Yes, ma'am.
Okay. Water, the outer cylinder should be kept at approximately the same level as the inner ring, but should not exceed the level of outer ring. So you have to maintain the same water level in the inner cylinder and outer cylinder as well. Then plot the data points in a graph of cumulative infiltration, again elapsed time in logarithm. Logarithm means the log table. So now you know the time, you know. So with the time interval, you can the 2 seconds. Then the interval is 4 seconds. Then the interval is again 2 seconds. By using this time, you can calculate the accumulated time. Here 2. 2 plus 4, 6. 6 plus 2, 8. So likewise, you can do the accumulated time. Then the drop of water, it is the infiltration. So for the first 2 seconds, the infiltration is 5 millimeter. The next 4 seconds, the infiltration is 6 millimeter. Again, after the 2 seconds, it's 4 millimeter. So with this infiltration, you can create the accumulated infiltration value. What is the accumulated infiltration here? It's 5. Then here, 5 plus 6, 11. Then 11 plus 4, 15. This is the accumulated infiltration value. So with this elapsed time means that accumulated, that interval. So that with the time and accumulated infiltration, you can draw your graph. Here, this is your elapsed time x-axis, and your y-axis is cumulative infiltration. You have to mention the units as well. But here, you are going to use log values. Then you can take the log values of each of these ones. Or else, if you are using your Excel sheet, first you can draw the normal graph, elapsed time and cumulative infiltration. Then you can double click in this x-axis and they will give some options. At that time, you can click the logarithm. Then this elapsed time is automatically changed into log value, log elapsed time. And likewise, you can change the cumulative infiltration and into log value. And it will give a graph like this. Measurements should be replicated at least 3 times in each side to reduce the variability. Normally, we will take more readings to increase the accuracy. That's why we will take this reading at least 3 times in each side. So first, take a suitable side. Then fix your double ring infiltrometer. Then set the point gauge. After that, place the plastic sheet in the bottom of inner cylinder. After that, fill the outer cylinder first and quickly fill the inner cylinder. Then take out that plastic sheet from the bottom of inner cylinder. Then by using stopwatch, you can note down the drop of water level. So that is the infiltration. Once the level of water level becoming less, you can refill the inner cylinder. At that time, the level of water in the inner cylinder and outer cylinder both are in same level. After that, you can plot your data points by using elapsed time interval and the cumulative infiltration. There are 3 methods used to measure the infiltration. Natural rainfall method, inflow-outflow method, and infiltrometer method. In the infiltrometer, we can use either single ring infiltrometer or double ring infiltrometer. In the double ring infiltrometer, then we can select constant head method or falling head method. So first, we will discuss what is this constant head method. In this method, the water level in the inner ring is maintained at a fixed level, and the volume of water used to maintain this level is measured. This is the inner cylinder. Clearly, your water is here. The inner level. once you mark the time, the 5-second time interval, you have to mark the depth. Again, you have to refill the water on the initial point. You have to refill. You have to add some volume of water to reach the water level to the initial point. So the water head is constant. Again, with the 10-second, it will go down. Again, you have to add the volume. So, but what is the unit of this infiltration? Millimeter per hour. So we can measure the time interval. But here, by using the volumetric flask, so by using the measuring cylinder, we know what is the measuring cylinder also initial volume. We know after fill this inner cylinder to make the initial level, at the end of pouring from this measuring cylinder, we know what is the volume of water we poured. So now volume we know. So how can you convert this volume into this depth? How can you convert? You need to divide your volume value by the area. How can you calculate the area of the inner cylinder? So already we talked the diameter of the inner cylinder is 30 centimeter, right? The diameter of outer cylinder is 60 centimeter. So now you know the diameter is 30 centimeter. So what is the area of the inner cylinder? Pi r square. What is the radius? If the diameter is 30, what is the radius?
15.
15. So pi into 15 square. That is the area. So once you know the volume, you can divide by area. Then you can get the depth of that water. Clear? So this is constant head method. You have to maintain that water level at the same level. That is constant head. What is falling head method? In this method, the time that the water level takes to decrease in the inner ring is measured. So in the procedure, we will discuss about this falling head. So with the time, the height of water drop is marked. Once the water level reach the bottom, at that time we need to refill. But the constant head method, each time we need to refill. In the falling head method, once the water level get the bottom, that time we need to refill. So we can select any of these, constant head method or falling head method, to use the measurement from double ring infiltrometer. $114. Vihara, your mic, please mute your mic. Thank you. No need to write. So with the stopwatch, we can take the time of reading. Then the elapsed time, the interval between two readings, we will write. Then the gauge reading. Gauge reading is the drop of the height of water. Then the intake. Once we use the constant head method, we need to add the volume. So we have to mark that intake. Then calculate the cumulative infiltration. So here this is data computation. Mostly this soil scientists, they use each type of soil has a particular amount of infiltration. So by using this method, they can create a function, drawing a graph, and they can use that for their future computations. So the cumulative intake, denoted as F, is defined as the total volume of water that has infiltrated through a unit horizontal area of soil surface over a period of time, measured from the beginning of infiltration. The cumulative infiltration is denoted as F, can be expressed as a function of time. So, in the practical, we mark the time and how the infiltration change with the time, where A and N are constant for a given soil at a given moisture content. So if you take a clay soil and a sand soil, the pore size between these soil particles are different. So the infiltration also different from soil types. And with the moisture content also, this infiltration will change. If the soil is saturated, the infiltration is less. So once you have one, so for the easiness, you can convert it into log value. So here you can take both side log. So log F is equal to log A plus this power n, it's coming from n log t. So this is a normal linear function. Y is mx plus c type. So with the, here this is your log t and this is log f. T is time, lapse time and cumulative infiltration, and take the log value and graph. So this point, it will interception in the y-axis, it will give log A, this log A, and you can get the slope and get n value. So by using this graph, you can develop an equation. Once you develop an equation for a particular soil type with the moisture content, you can use it anywhere. So this is the use of this data computation. So no need to worry much about these equations, just for your knowledge. Okay, let's move to the example 1. Calculate the rate of infiltration. Please quickly write down this. This is the time interval, and this column is depth of water infiltrated. The time interval, it's in second. The water infiltrated is in millimeter. Then rate of infiltration. So it's millimeter per second. So first they start from 0, the stopwatch. Then this is 4 seconds, 8 seconds, 12 seconds, 16 seconds. So normally in the recordings, it's like this. The time is 0, 4, 8, 12. But the time interval, we can directly give the interval between these two readings. It's 4. So tell me, what is the rate of infiltration in the first 4 seconds?
1.25.
Yes, 1.25. Likewise, for each time interval, you can measure the rate of infiltration. See, this is the example 2. So you can take down the readings from the practical. The data sheet is similarly like this. So no need to write each of these rows, just 3 or 4 rows are enough. So I'll tell how they calculate. First, reading on the clock. So they use the clock. So the time is 14 hours, 5 minutes, 0 seconds. The second column is time difference, means time interval. It's in minutes. Then cumulative time. So first they start in 14 hours and 5 minutes. They take the first reading in 14 hours, 7 minutes. So the interval between these two readings is 2 minutes. The second reading is, so the 14 hours, 10 minutes. The difference between these two is 3 minutes. After that, 14 hours, 15 minutes. The difference is 5 minutes. So likewise, in this column, they'll write the time difference. The next column is cumulative time. What is cumulative time? We have to add the previous time. So for the first reading, the initial reading is, we started at 0. So 0 plus 2 is 2. 2 plus 3, 5. 5 plus 5, 10. 10 plus 10, 20. Likewise, we can compute the cumulative. It's in minutes. The fourth column, water level reading. So here they will use the constant head method. So first, the initial reading is 100 centimeter. Sorry, 100 millimeter. At the end of 2 minutes, the reading is 92 millimeter. So what is the infiltration between these 2 minutes? The difference between these two readings. So initially it's 100. After 2 minutes, it's 92. The infiltration is 100 minus 92 is 8 millimeter. After 2 minutes, they again refill and reach the initial reading as 100. So at the end of another 3 minutes, the reading is 93. So what is the difference? 100 minus 93 is 7 millimeter. After that, they refill. But this time, it's not reach 100. It's in 99. At the end of another 5 minutes, the reading is 89 millimeter. So what is the infiltration now? The difference between 99 minus 89 is 10 millimeter. Then again they refill. But this time it's reached 101 millimeter. Then again at the end of 10 minutes it's reached 84 millimeter. So the difference is 101 minus 84 is 70. So likewise, we can calculate the infiltration. After that, the infiltration rate. So what is the infiltration rate is? Infiltration over time. So infiltration is 8 millimeter. The time difference is 2. So what is the infiltration rate? 8 by 2 is 4 millimeter per minute. For the next time interval, the infiltration is 7. The time interval is 3. So 7 by 3 is 2.33. For the next one, the infiltration is 10. The time interval is 5. So 10 by 5 is 2 millimeter per minute. The next column is infiltration rate. They expect in millimeter per hour. Here it's millimeter per minute. So how can we convert this minute into hour? How can we convert minute to hour?
Dividing 60.
Yes, divided by 60. So now it's 4 millimeter. How can they get 8 millimeter over 2 seconds? Sorry, 2 minutes. To convert this minute into hour, again we divide by 60. So it's 8 divided by 2, then 2 divided by 60. So the 60 is coming here. 8 into 60 divided by 2. So that is 240 millimeter per hour. So directly you can multiply it by 60. For the next interval, the infiltration rate is 2.33. So you can multiply it by 60 and get the value in millimeter per hour. So likewise, we can get infiltration rate. In the last column, it's cumulative infiltration. So for the initial infiltration is 0. At the 2 minutes interval, the infiltration is 8 millimeter. Then it's 7 millimeter. So what is the cumulative initial? It's 8. Then 8 plus 7, 15 millimeter. 15 plus 10, 25 millimeter. So likewise, they will give the cumulative infiltration. So once you understand how they will calculate each portion, then it's easy for you. First, with the stopwatch, they can get the time interval and develop the cumulative time. Then the drop in water level, from that they can get the infiltration. With the infiltration value, they can get the cumulative infiltration. Then calculate the infiltration rate. Then you can, once they ask to convert it into a particular unit, then you need to convert it. Or else you can leave it as millimeter per minute. Just 3 to 4 rows are enough. Have you finished?
Yes, ma'am.
Yes. So this is your third example. I take this example from a textbook. So no need to write this paragraph. I will tell the important points you have to write. Right? First, I read this. Kevin, the new civil engineer, is asked to perform capacity testing on a dry soil located along a highway. He chooses to use the double ring infiltrometer and sets it up at the site using an inner ring with a diameter of 8 inches and the outer ring diameter of 24 inches. Water is filled in the inner ring and outer ring to a particular depth of 4 inches. And this depth is maintained in the range of 2 to 3 inches throughout the experiment. So they have to maintain that level in a particular depth. That is constant head method. The volume of water added each time to bring the water level in the inner ring reaches to 4 inches is recorded along with the time interval between filling times as shown in the table below. So from this paragraph, the only information you need to calculate is the diameter of inner ring is 8 inches. That's enough. So in your example 3, first you have to write the diameter of inner ring is 8 inches. Then you can write this table. Time from beginning and the volume added. From this, you can calculate the cumulative infiltration and infiltration rate. So this time, they didn't give the drop of water level, not in the depth. Here, they will give the volume added. So from the information that diameter of inner ring, from that you can calculate the area of the inner ring. Then you can divide that volume by area. and calculate the depth. Here they give the time from beginning. So you can take the time interval. For the first reading, it's 200 seconds. For the next reading, 600 minus 200 is 400 seconds. For the next reading, 1100 minus 600 is 500. So likewise, you have to first calculate the time interval, then calculate the area is common for all. So first you can calculate the area, then divide that value and calculate the infiltration rate. Diameter is 8 inches. So the radius is 4 inches. So what is the area of inner cylinder? A is pi 4 squared inch, that is 16 pi. So for what is the depth of first value? 45 inch cube divided by 16 pi. So what is the depth? Sixteen pi is nearly 50.265. So the depth is 45 divided by 50.265. 45 divided by 50.265 is 0.895 inches. Then you have to calculate the infiltration rate. So infiltration rate is infiltration over time. So what is the time? It's 200. So again, you have to divide by 200. Once you need to convert the unit from seconds to hour, how can you convert this seconds to hour? You have to divide by 16 to 60. For the first 60 is convert this second into minute. Then again 60 is convert that minute to hour. So you have to divide by 3600 to convert this into hour. Have you write down this table? Finish?
Yes, ma'am.
Okay. Okay, from the time from beginning, they will give. So the time interval, you can calculate the difference between these two readings. You can calculate the time interval. Then from the volume, here directly I give the final infiltration rate in inches per hour. Now you can convert this volume divided by area, and you can here you can write the depth in inches. After that, if you want, you can add another column, infiltration rate in inches per second. Then you can write infiltration rate inches per hour. So can you calculate? Now you know the procedure. So can you? Yes. So wrote down this answer somewhere and you can compare it later. Okay, you can do it. So no need to write this one. This is the application, practical application. So here, just observe on the slide. Here the observed clock time. So clock time they will give. From the clock time, you can write the time interval. Okay, it starts from 12:55. Now it's 12:56. So the time interval is 1 minute. After that, it's 12:56. The time interval is 2 minutes. Likewise, you can write the time interval. After that, time elapsed, that accumulated time. First, it's directly 1. Then 1 plus 2, 3. 3 plus 2, 5. Likewise, elapsed accumulated time interval. Then, initially the water level is in 12 centimeter. At the end of 1 minute, it reaches 12.5. So the difference is 0.5. That is the infiltration depth. At the end of another 2 minutes, it's reached 13 centimeter. So the difference is again 0.5. So likewise, they can get the infiltration depth. Then accumulated infiltration, for the first row, you can directly put 0.5. Then 0.5 plus 0.5, it's 1. So likewise, accumulated infiltration is here. So how can you get the average infiltration rate? So for the average infiltration, you have to add the infiltration depth. So you can add these values together and get the total, or else you can directly use the last value from the accumulated infiltration. Why? In this column, you already add 1 by 1. Here 0.5 plus 0.5, again plus 0.4. Likewise, you add together and get the final value. So you can directly use this accumulated infiltration value. Then average infiltration rate is accumulated infiltration over total time. So in this column, you need to add everything and get the total time, or else you can directly use the last value from the accumulated time interval. So you can directly use that. So 3.8 divided by 52 minutes. So you need to convert this minute into hour. So already this 52 is dividing. So this 60 is automatically coming up. So you have to multiply it by 60 and get the average infiltration rate as 4.38 centimeter per hour. And here, this is a graph between elapsed time interval versus average infiltration rate. this average infiltration rate with the elapsed time interval. The graph is something like this. After that, to get a linear value, we already discussed, we have to take log values. So we have to convert this accumulated time into log time, and this accumulated infiltration into log value of that accumulated infiltration, and develop a graph. From this graph, you can get the intercept A is equal to 0.44. From the slope, you can get the n, and finally y is equal to at to the power n. Now you know the a and your n values, and you can create this type of standard equation. This is for the data computation purpose. So for the today's practical, we'll discuss about the infiltration, and the unit of the infiltration is millimeter per hour. To measure the infiltration, we can use three methods: natural rainfall method, inflow-outflow method, or infiltrometer method. In the infiltrometer method, we can use double ring infiltrometer. To take the values, we can use either constant head method or falling head method. So in the methodology, first you have to select a suitable site for your experiment and clean the vegetation. After that, dig a 10 centimeter depth hole and insert your cylinder. For the installation purpose, you can use wooden plank and hammer. Then you have to insert it vertically and uniformly. After that, you have to set a point gauge or hook gauge in the inner cylinder. After that, you have to place a plastic sheet inside the inner cylinder and fill the outer cylinder and inner cylinder. After that, remove that plastic sheet, and you need to note down the time and the drop of water level. Then you can draw a graph. So that's all for the day. Is it clear? Is it clear?
Yes, ma'am.
Ma'am.
Yes, ma'am.
Yes. So this is your last practical regarding with hydrology. Most probably next week onwards, you will start your drawing practicals. So that's all. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.